Good morning, students. Today we will be going to study about next chapter, that is general principles and processes of isolation of elements. Students, we know that most of the metals they exist in combined forms in the earth's crust. Such metals in the combined form which are present in the earth's crust are called minerals. And from these minerals, metals can be extracted profitably. Such type of minerals from which metals can be extracted profitably are called ores. Generally, ores they are contaminated with earthly or undesired material known as gangue. Therefore, the extraction and isolation of metal from the ore involves the following major steps, that is concentration of the ore, which means removal of gangue from the ore, isolation of the metal from its concentrated ore, and finally purification of the metal, which is known as refining. And this entire scientific and technological process used for isolation of the metal from its ore is known as metallurgy. So in simple language, we can say it is a scientific study of metals and their uses. Let's discuss the first important step in metallurgy, that is concentration of ores. Now, concentration of ore means the removal of unwanted materials, that is sand, clay, etc. from the ore, and this is also known as dressing or benefaction. Now, some of the important procedures which are used for concentrating of ores are hydraulic washing, magnetic separation, froth flotation, and leaching. First, discuss about hydraulic washing. Now, hydraulic washing, it is based on the difference in gravities of the ore and gangue particles. In this process, an upward stream of running water is used to wash the powdered ore. The lighter gangue particles are washed away and the heavier ores are left behind. Which means हम इस प्रोसेस में ग्रेविटी को बेस बना के गैंग को ओर से रिमूव करने की कोशिश करते हैं। इस केस में रनिंग वाटर की हेल्प से हम क्या करते हैं, गैंग को रिमूव करते हैं ओर से। तो गैंग पार्टिकल्स जो लाइटर होते हैं वो वाटर के साथ वॉश अवे हो जाते हैं, वेयर एज जो हैवियर ओर पार्टिकल्स होते हैं वो पीछे रह जाते हैं। नेक्स्ट मेथड इज मैग्नेटिक सेपरेशन. This method is based on difference in magnetic properties of the ore components. That means it is applicable if either ore or impurities are magnetic in nature. That means they can be used to separate iron ores from gangue. As we know that iron ores they will be magnetic in nature, and gangue, that is sand, etc., rocks, etc., they will be non-magnetic in nature. So the grounded ore, that means the powdered ore, it is carried on a conveyor belt. This is the conveyor belt which passes over a magnetic roller. So this is your magnetic roller. So when the powdered ore is passed over this magnetic roller, then the magnetic iron ore, it will be attracted towards the roller and it will be collected in the container that is present near the roller, whereas the non-magnetic gangue particles, they will be pushed away from the roller and they will be collected separately in another container. मतलब इस केस में हम फाइनली जो पाउडर्ड आपका ओर होता है along with gangue particles, उसको हम एक कन्वीनियर बेल्ट पे मूव करवाते हैं, जिस कन्वीनियर बेल्ट में एक मैग्नेटिक रोलर लगा होता है। तो जो आयरन पार्टिकल्स होंगे या आयरन ओर होंगे, वो ओर्स क्योंकि मैग्नेटिक है तो वो मैग्नेटिक रोलर की तरफ को आ जाएंगे, जिसकी वजह से वो एक अलग कंटेनर में जो मैग्नेटिक रोलर के पास होगा उसमें कलेक्ट हो जाएंगे, वेयरएज जो गैंग पार्टिकल्स होंगे वो उससे अवे यानी दूर की तरफ इकट्ठा होंगे, एक सेपरेट कंटेनर में कलेक्ट हो जाते हैं। नेक्स्ट मेथड इज froth flotation method. Now this method is used for removing gangue from sulfide ores, and the basic principle involved is that sulfide ores are wetted by oils, whereas gangue particles are wetted by water. So in this method, a suspension of powdered ore is made with water, and to it collectors and froth stabilizers are added. What do you mean by collectors? Collectors are those substances which enhances non-wettability of the mineral particles, for example pine oils. And froth stabilizers are those substances which stabilizes the froth, which means form in the process. Now this finely powdered ore along with collectors and stabilizers, when added to water, then mineral particles, they will be wetted by oils, whereas gangue particles are wetted by water. And a rotating paddle. This paddle, it is used for churning the mixture, and when the mixture is rotated at a high speed, then a froth is formed on the surface of the water, and all the mineral oils or mineral particles, they will be carried into the froth as they are lighter, whereas the gangue particles, they will remain behind in the water. Now this foam or froth containing the mineral ores, it can be skimmed off, it is then dried, and from where ore particles are recovered. Meaning फ्रोथ फ्लोटेशन मेथड से हम गैंग को सल्फाइड ओर से रिमूव करते हैं। इस प्रोसेस में हम क्या करते हैं, सल्फाइड ओर्स को वाटर में मिक्स करते हैं और उसके अंदर हम ऑयल्स को डालते हैं, जो ऑयल्स कलेक्टर्स का काम करती हैं, और हम इस मिक्सचर को अच्छी तरह से चर्न करते हैं, रोटेट करवाते हैं। होता क्या है कि जो सल्फाइड ओर्स हैं वो ऑयल में अच्छी तरह से वेट होते हैं, यानी वो ऑयल में जाएंगे, और जो गैंग पार्टिकल्स होते हैं वो वाटर से वेट होते हैं, यानी वो वाटर में रहेंगे। तो रोटेट करने पर जो ऑयल है वो सरफेस पे आ जाएगा और सरफेस पे आके एक फ्रोथ बना लेगा, यानी एक फॉर्म झाग टाइप से बना लेगा, और सारे के सारे जो मिनरल पार्टिकल्स होंगे यानी ओर पार्टिकल्स होंगे वो उस फ्रोथ में चले जाएंगे, जबकि जो गैंग है वो वाटर में नीचे रह जाएगी। और इस फ्रोथ की स्टेबिलिटी को मेंटेन करने के लिए हम इसमें फ्रोथ स्टेबलाइजर्स मिक्स करते हैं। अब इस फ्रोथ को इजीली रिमूव किया जाता है, और रिमूव करके इसको ड्राई करके इसमें से ओर पार्टिकल्स को रिकवर कर लिया जाता है। We can also use this method to separate two sulfide ores by adjusting their proportion of oil to water or by using depressions. Now, what are depressions? First of all, let us understand depression. Now, depression is a substance that selectively prevents one of the sulfide ore from coming into the froth. For example, if an ore contains two types of sulfides, let us say zinc sulfide and lead sulfide, then we add sodium cyanide to the solution. This sodium cyanide, it prevents zinc sulfide from coming into the froth, but it allows lead sulfide to come into the froth. That means in froth we will be only having lead sulfide, whereas zinc sulfide will remain in the water. So here we can separate lead sulfide from zinc sulfide also with the help of a depression. Another method is bleaching, which involves the treatment of ore with a suitable reagent which dissolves ore but not the impurities. That means ore is soluble in a particular solvent but not the impurities. For example, bauxite ore, that is an ore of aluminium, it is leached with sodium hydroxide to obtain alumina, that is aluminium oxide. Now, bauxite, it contains silica, iron oxide and titanium dioxide as impurities. So basically the powdered ore is dissolved in sodium hydroxide, and now dissolving it in sodium hydroxide, aluminium oxide will go into the sodium hydroxide to form sodium aluminate. Then this sodium aluminate is further treated with carbon dioxide to form hydrated aluminium oxide, and this hydrated aluminium oxide is further heated to give dry aluminium oxide, that is alumina. So basically इस केस में हमने एल्यूमिना यानी एल्यूमिनियम ऑक्साइड को हमने बॉक्साइट ओर से रिकवर किया है विद द हेल्प ऑफ लीचिंग. अब क्योंकि जो एल्यूमिना था, एल्यूमिनियम ऑक्साइड था, वो सोडियम हाइड्रोक्साइड में डिसॉल्व हो जाता है, गैंग पार्टिकल्स डिसॉल्व नहीं होंगे. तो फर्स्ट इक्वेशन जो हमने पढ़ी थी उसमें एल्यूमिनियम सोडियम हाइड्रोक्साइड में डिसॉल्व होके सोडियम एल्यूमिनेट में कन्वर्ट हो गया, और इस सोडियम एल्यूमिनेट को हमने सेकंड इक्वेशन में कार्बन डाइऑक्साइड से ट्रीट करके हाइड्रेटेड एल्यूमिनियम ऑक्साइड में कन्वर्ट किया, और हाइड्रेटेड सॉल्ट्स को जब हम हीट करते हैं तो वो ड्राइड सॉल्ट्स में कन्वर्ट हो जाते हैं, यानी हमें एल्यूमिनियम ऑक्साइड रिकवर हो गया. तो दिस प्रोसेस इज नोन एज लीचिंग. After the concentration of ores, next step involved in metallurgy is extraction of crude metal from concentrated ore. In this process, the ores are first converted into oxides and then they are reduced. This is because it is easier to reduce an oxide as compared to sulfide ores and carbonate ores. So basically, the two important steps involving isolation of metals from concentrated ores are conversion to oxide and reduction of oxide to metal. So first of all, conversion to oxides, and it will involve two processes, calcination and roasting. Now calcination is a process which involves conversion of carbonate ores into oxides in the presence of limited supply of oxygen. Whereas in roasting, sulfide ores are converted into oxide ores in the presence of excess of oxygen. Here zinc carbonate, it is converted into zinc oxide and carbon dioxide. This process is called calcination. Whereas this equation where zinc sulfide, that is sulfide ore, is converted into oxide ore in the presence of oxygen, this is called roasting. And once we obtain metal oxides from metal carbonates and metal sulfides, we can reduce these metal oxides using suitable reducing agents to form crude metals. Let's discuss the steps involved in the extraction of iron from iron ore. Now the extraction of iron takes place in a blast furnace where ore, limestone and coke is introduced from the top, whereas hot air is introduced from the bottom of the furnace. Coke is heated at the bottom of the furnace, due to which temperature at the bottom of the furnace reaches up to 2200 Kelvin. Now the heat along with carbon monoxide produced, it will rises upward in the blast furnace, but the temperature keeps on decreasing as we move from bottom to the top in a blast furnace. The temperature ranges at the upper portion of the blast furnace ranges between 500 to 800 Kelvin. At the middle, it ranges between 900 to 1500 Kelvin, and at the bottom it ranges between 1500 to 2200 Kelvin. Now ore is introduced from the top, that means iron oxides, which can be your ferric oxide or ferric oxides, they are introduced from the top and they will have to pass through these different layers in the furnace which are having different temperature ranges. So the reduction of these ores or oxides, it will take place at different temperatures, and let us discuss them one by one. So at the temperature range of 500 to 800 Kelvin, the ferric oxide, it is reduced by carbon monoxide to form ferroferric oxide, and this ferroferric oxide is further reduced to form iron. At 900 to 1500 Kelvin, carbon, that is coke, it will convert carbon dioxide to form carbon monoxide, and this carbon monoxide further reduces the ferrous oxide to convert into iron. And at the temperature above 1570 Kelvin, following reactions takes place. The ferrous oxide is reduced by coke, that is carbon, to form iron. Now what is the purpose of limestone in this process? Limestone decomposes to form calcium oxide, and this calcium oxide, it reacts with silica. Silica is impurity. It reacts with silica to form calcium silicate, which is slag. And now this slag, it can be removed from the bottom of the furnace in molten form, and the iron, it is obtained from other side, and this iron is called pig iron. Next, we have extraction of copper from copper ore. Now copper exists in the form of copper sulfide, and these sulfide ores, they can be first converted into copper oxides using roasting process, which can be later on reduced with the help of carbon to convert into copper. Now most of the sulfide ores, they contains iron, and this iron has to be removed since it is an impurity in copper ore. So actually ore is heated in a furnace after adding silica. We add silica to the ore and then we heated that ore for roasting process. Now what happens? Iron oxide, which will be present in the ore, it will react with silica and will convert into ferrous silicate, that is your slag, and this slag will be removed from the ore, and we will be getting a copper matte, which means we will be getting a mixture of copper sulfide and ferrous sulfide. Now we have to separate this ferrous sulfide again from copper sulfide. For this process, we again heated the ore in oxygen, and due to the heating, ferrous sulfide will be converted into ferric oxide, and this ferrous oxide, it will react with silica again to convert into slag, which can be removed. So we are only having copper sulfide, which will be converted into copper oxide by roasting, and this copper oxide will later react with copper sulfide. That means it will undergo self reduction to convert into copper. Now during this process, sulfur dioxide is also produced. That means the copper obtained will have a blistered appearance on its surface due to the evolution of sulfur dioxide. Therefore this copper is also known as blister copper.